So in this video we're going to find the reduced row echelon form of a matrix. So here's the matrix that we're going to work with in this problem. The matrix is A, and it has 3 rows and 4 columns, and you can see it right there. We are going to take this matrix A, we're going to perform row operations on it to get it into what we call reduced row echelon form. And you'll see what that form means here as we go along. In general, what it means is that the first entry that you come across in any row needs to be a 1. So the way I think about this is I always start with the first row and I make sure that the first non-zero number that I encounter is a 1. So we're kind of off to a good start already with a 1 there. And then below that 1 there has to be zeros. So there have to be zeros right here. And then so right now I like the 1 here, but I don't like these because they're not 0. So after we make these 0, then in the next row, the first entry that I need to come to is a 1. So I need to have zeros going this way until I hit a 1. And then once I hit that 1, there need to be zeros below that as well. So the idea is to get 1s with zeros below it. And you do that by doing row operations. So the first thing I'm going to do is I'm going to get rid of the 4 and the 7 by letting equation 2 equal equation 2 minus 4 times equation 1. And I'm going to let equation 3 equal itself minus 7 times equation 1 to cancel out these 4 and 7 right there. So equation 1 stays the same. I end up with a 0 there for equation 2, a negative 3 here, because 5 minus 2 times 4 is a negative 3. And if you just continue the simple computations there, you end up with a negative 6 and a 7. And then I'll do similar type operation here for the third row. The third row minus 7 times the first row gives me a 0 there, because 7 minus 7 times 1 is 0. And then I end up with 8 minus 14 is a negative 6. 9 minus 21 is a negative 12. And 5 minus a negative 1 times 7 ends up being 5 plus 7, which is 12. So I'm off to a good start. I have a 1 right here, and I have zeros below it. But now in the second row, the first non-zero thing that I come across is negative 3. So I don't like that negative 3 there. Same thing here. I don't like this negative 6 here either. So we're going to start working on this next column. So if I let equation 3 equal equation 3 minus 2 times equation 2, I can get a 0 right there. So equation 1 and equation 2 remain unchanged. I end up keep a 0 there, and then I'll have a negative 6 minus a negative 3 times 2, which gives me a 0. Then a negative 12 minus a negative 2 times a negative 6 gives me 0 there as well. And then I get a negative 2 here when I do 12 minus 7 times 2. It's 12 minus 14 is a negative 2. Okay, so we're getting there. Got some zeros there. Let's go ahead and let equation 3 equal 1/2 times, or negative 1/2 times equation 3. We're going to turn this into a 1, because remember, in any row, the first thing that I come across has to be a 1. So as I'm going across this row, I have 0, 0, 0, then I have a negative 2. I can't hit a negative 2. I have to hit a 1. So I can turn a negative 2 into a 1 by multiplying by negative 1/2. And then we'll do something similar here for equation 2. If we multiply equation 2 by a negative 1/3, that will turn a negative 3 into a negative 1. We'll have that 1 sitting there like we like. So after we do this multiplication, we have the 1 there in equation 2. We get the 1 in equation 3 like we would like. And now we're getting there. We're almost done. I have 1 with zeros below it. I have a 1 with zeros below it. The next thing that I need to do is get rid of some of these other entries right here. If I let equation 1 equal equation 1 minus 2e2, so only equation 1 is going to change, so I'll only copy down e2 and e3 by themselves without changing in equation 1. I end up with a 0, and with this. Then we'll go ahead and let equation 2 equal equation 2 plus 7/2 equation 3. So I'm only going to change equation 2. Still have a 0 there, still have a 1 there, and I can cancel out that negative 7/2. So after doing this, I end up with this matrix right here. You might be wondering, why are we trying to get rid of these entries? Well, one of the other rules about the reduced row echelon form is that any column that has a pivot, and these are what we call pivots, these 1s, that can be the only non-zero term there. So we're glad that we have a 1 right here, but the fact that these are non-zero is a problem, so we need to get rid of those. So I've gotten rid of one of those right there. I can keep going. If I let E1 equal E1 minus 63, we can get rid of this right here, and then we'll end up with this final matrix after we do the computations that looks like this. And this is in fact the reduced row echelon form of the matrix. I can check this. In the first row, the first non-zero entry that I come across is a 1, and it is the only non-zero entry in this column. In the second row, the first non-zero entry that I come across is a 1, and it too is the only non-zero entry in this column. And then finally in the third row, the first non-zero entry that I come across is a 1, and it is the only non-zero entry in this column. So this is the reduced row echelon form of the matrix.